The two most abundant elements in the universe, hydrogen and helium, make up less than 1% of Earth's composition for a variety of reasons. On a cosmic scale, hydrogen is abundant primarily because so much of it was produced during the Big Bang. In the initial moments after its birth, the universe was a cloud of quarks and gluons. Once things stabilized, most of the observable matter consisted of electrons, protons, and neutrons, along with some less familiar subatomic particles. Electrons and protons typically combined to form hydrogen. A small amount of helium and even less lithium were also created. Most primordial lithium was destroyed in stars, but those same stars also fused hydrogen to create helium and other elements in the periodic table during their later stages of life. However, hydrogen and oxygen are present in a 2-to-1 ratio in the oceans. Some hydrogen is bound in rocks or carbon molecules like methane in the atmosphere. But in terms of the atomic makeup of the planet, there's not a lot of hydrogen. Helium is even scarcer, so much so that no one paid attention to it until its spectral lines were detected during a solar eclipse. Like all planets, Earth formed from the protoplanetary disk, which consisted of hydrogen and helium from the Big Bang, along with some heavier elements fused in early stars and scattered across the galaxy by supernovae and kilonova explosions. The Sun and the gas giants in the solar system reflect this composition, though most of the Sun's original hydrogen has since been converted into helium. Earth and the inner planets, however, are entirely different. Despite their cosmic abundance, hydrogen and helium are both very light gases, meaning they easily escape Earth's gravitational pull. Larger planets like Jupiter retain more hydrogen and helium due to their stronger gravity, whereas Earth's gravity is not strong enough. Additionally, Earth is much closer to the Sun than the gas giants, so gases here are warmer, more energetic, and more likely to escape. Helium is especially rare because it is an inert gas, meaning it almost never bonds with other atoms that could hold it tightly enough to prevent its escape. Most planetary scientists believe that Earth's original helium from the protoplanetary disk no longer exists. The helium we have now mainly comes from the radioactive decay of heavier elements. A common form of decay produces alpha particles, which consist of 2 protons and 2 neutrons bound together, essentially the nucleus of a helium-4 atom. Once released, the alpha particles can capture electrons from their surroundings to form helium. If released near the Earth's surface, helium atoms are likely to rise into the atmosphere and then escape into space. However, helium produced deep underground through radioactive decay can get trapped in pockets of rock. Though often associated with balloons, helium has more critical uses, such as cooling scientific equipment and MRI machines to temperatures too low for alternatives like liquid nitrogen. Helium supplies depend on drilling in areas where it has accumulated over millions of years. Most helium reserves are collected as a byproduct of methane drilling. Hydrogen is more abundant on Earth than helium because it readily bonds with other elements like oxygen. A water molecule is 9 times heavier than an H2 molecule, making hydrogen less likely to escape. However, much of the hydrogen in the planet's primordial matter has long since disappeared, especially during collisions that turned Earth's surface into a magma ocean.